Power distribution systems. A 1500 watt electric heater is plugged into the outlet of a 120 volt circuit that has a 20 amp circuit breaker. You plug an electric hair dryer into the same outlet. The hair dryer has power settings of 600 watts, 900 watts, 1200 watts and 1500 watts. You start with the hair dryer on the 600 watt setting and increase the power setting until the circuit breaker trips. What power setting caused the breaker to trip? Because this electric heater and hair dryer are connected to the same outlet, they are connected in parallel, and the total current that flows in the circuit will be the sum of the two currents passing through the heater and through the hair dryer. Now we know that the electric heater power is related to the voltage across it multiplied by the current, and because it's 1500 watts electric heater, the voltage is 120 volts, then the heater RMS current that will flow through it will be 1500 divided by 120, 12.5 amps. The total RMS current that flows through this circuit will be the sum of the current flowing through the heater and through the hair dryer. So I can write I total RMS is equal to I heater RMS plus I dryer RMS. So the current that can pass through the dryer, I dryer RMS, will be the maximum current the circuit can handle, is determined by the circuit breaker, 20 amps minus 12.5 amps, 7.5 amps. So the power dissipated by the dryer will be 120 volts multiplied by 7.5 amps, 900 watts. So if the power on the dryer exceeds this value, it will draw too much current and the circuit breaker will trip. So you can think of the circuit breaker as a switch here. So this is basically a switch that is controlled by the current S. The switch actually is normally closed. It will opens at I total RMS is equal to 20 amps. So this switch is normally closed, but it will disconnect the circuit, the power supply from the rest of the circuit, the load, when the current exceeds 20 amps. So I will find that for the power of the dryer greater or equal to 900 watts, the circuit breaker trips. It breaks the circuit, the switch opens. Okay, so the power setting can be increased to 600 watts to 900 watts, but when it reaches 900 watts, it will trip, so we cannot really increase the power setting that much. Even for 900 watts, we will reach 20 amps and it will break the, it will cause the circuit breaker to trip. So here, the hair dryer and the heater connected in parallel to the same voltage source, and there is a circuit breaker in the circuit which is going to open at a maximum current of 20 amps. Because these two currents add up, the total current should not exceed 20 amps. The power rating of the heater is 1500 watts. So for 120 volts voltage, it's going to draw a current 12.5 amps. So that's the power it has to dissipate. Now there is 7.5 amps left for the hair dryer because they will add up to give the total current, and that 7.5 amps with the 120 volts will imply 900 watts being consumed by the hair dryer. So 600 watt setting is okay, but 900 watt setting will cause the circuit breaker to trip. So we cannot go to 1200, 1500. At 900 it just trips the circuit breaker.